So here we have a truss system, and what we intend to do is to analyze this system using the method of joint. And what our analysis will look like is us knowing exactly how much force is going through each member and the nature of the force, meaning if that force is in tension or if it's in compression. So we can either have ties, which are for members in tension, or we can have strut, which are members in compression. So let's go ahead and start the analysis. And what we'll notice first of all is that each side measures 6 meters. So what we should infer from all of that is that we have equilateral triangles. And what that means, each angle, each internal angle will measure 60 degrees. So the first thing that we need to be able to do is to calculate the reaction forces. And to do that, I'm going to ensure that you can see this line of action right there coming down the middle. So that's where our force is acting, because we need to do force multiplied by perpendicular distance in order to do that. So with that then, we're going to take the sum of the moment. So that's our sum of the moment at R1. That should be equal to 0. So now if we take clockwise moment on this side, so say clockwise moment should be equal to our counterclockwise moment. So that 15 newtons, if we were to imagine that this thing would be rotating right there at R1, would that be going clockwise or counterclockwise? And of course you can see it's gonna go clockwise. So what we would have is 15 multiplied by the length. So if each member, the side is 6 meters and this comes right down the middle, then that's 15 multiplied by 3. Then we go across to that next 9 newtons. So that 9 newtons again will be trying to rotate this system in the same clockwise motion. So if all of this from here to here is 6 meters, then half again from there would be 3 meters. So that would then give us plus a 9 multiplied by 9. Now, those are the only forces that will be trying to pivot this thing in a clockwise motion. So the next force that we have is then R2, and R2, its distance from our pivot point there is 12. So then all we need to do is just to sum these amounts. So we have 15 times 3. So that's our 45 plus our 81 equals 12 times R2. So therefore our R2 is equal to, that's 126 divided by 12. So our R2 value is 10.5 newtons. So that's R2 done. And then now to find our R1, we're going to just say that our upward vertical forces should be equal to our downward vertical forces. And what's going upward, it's just R1, and we're assuming it to be R2 again. And what's going downwards, it's just 15 plus 9. So then to get our R1 value, we already know R2, so all we're going to do is just to subtract that R2 from 15 plus 9, 24 minus our 10.5, and that gives us our R1, 13.5 newtons. So that's the reaction forces, and that's step 1 done. So I'm just going to fill these in, clear the space, and start the analysis. So the first part of our analysis is to look at the forces that are acting at that bottom left joint. We could have used other joints. We could have started with the bottom right, but I've chosen to use bottom left. And to do that, what we need to first understand is how to break our forces up into components. And the components that we're talking about here are just the vertical and the horizontal components. And what that looks like, so if we were to set up our equations for vertical force components and horizontal force components, what you are looking for is which one of these equations will have only one unknown. And let me show you what that looks like. So right here, I have isolated that joint. So this right here is our joint with our reaction of 13.50. And we have that member AB. And down here, we have that member BG. So just to ensure that you understand the notation, I'm using Bose notation. And when I say AB, member AB, it's just this member highlighted in blue. And it's AB because that member is in between the letters A and B. And if I'm to come across to this one and say BG, it's because that member is in between B and G. As for R1, it's just going to be R1, and that's it. So let's look at the analysis here. So for the vertical force components, what we have going up, first of all, is R1. So we can just start with that. So that's 13.50. And that's just a vertical force. So its actual value is what you see there, which is 13.50. It has no horizontal force component. And then now we're going to go across to member AB. And we're going to assume to begin with that it's going to be positive. We don't know yet. So what we're going to have is AB. And this angle right here is 60 degrees. We already know that. So we're going to have AB sin 60. And because BG is just a purely horizontal force, then BG won't be a part of this equation. So that's what we'll end up with, and that will be equal to 0. Now, just for you to compare the two equations, I'm now going to set up the horizontal force components. And for that, we won't use R1 because that's just a vertical force. So what we would have is BG. So that's our BG. It's just horizontal, so no BG sin or cos. So BG plus, in this case, AB cos and 60 equals 0. So as you can see, in one equation, we have only one unknown. And then in the other, we have two unknowns. So what we have to do, what we always have to aim at, is to solve the equation, first of all, with only one unknown. And in this instance, it's AB. So I'm just going to go ahead and get the value for AB. So AB would be equal to, so we have 13.50, which will be negative when we solve that. That's divided by sin 60. And our final answer there is AB is negative 15.59. That's newtons. So that's our AB done. So now that we have AB, what we can do now is use the value that we just calculated for AB and substitute it in this next equation down here so that we have only BG left as an unknown. And because now I know that AB is negative, I can just substitute this as negative 15.59 and cos 60 equals 0. So then when we pop that in the calculator, BG minus 7.80 equals 0. So therefore our BG is a positive 7.80 newtons. So there we go. That's the first two members analyzed. So we have our force value there for BG and our force value there for AB. And BG is in tension and AB is in compression, or we can label them as ties and struts. So we're going to go now to the top left corner to analyze that joint. So we're going to adopt the same approach. So I'm going to set up the two equations, one with vertical components and the other with horizontal components. And let's start off with the vertical force components. And for this one, what we have that 15 newtons, and that 15 newtons, it's going down, so hence negative 15. And then now we have that AB, which we already know the value for AB, but just for now, I'm just going to set up a general equation. So I'm just going to have plus AB. And this time around, it's very important for you to understand the value that I'm going to use for the angle. So I'll highlight AB in this blue. right there. And if you can imagine, this angle should be measured counterclockwise from the right. So right there is the angle that I've drawn for AB, and its measurement is going to go around like that. So that's simply going to be 180 plus that next 60 degrees there. So what I'll write now for that is AB, and it's sin. And if we do follow our angle, is sin 240. And then we go across now to BC, so plus BC now. And the angle, we're just going to go another 60 degrees there. So plus BC sin, and that's 300 degrees equals 0. And then we set up the equation for the horizontal components now. And you don't have to do this because you'll have only one unknown value in the vertical components most of the time. But I like to show it just so that you understand, or just so that you appreciate the process. So for the horizontal force components, what we'll have CD and plus AB. It's just going to be AB cos 240 now, same thing as up top, and then plus BC and then cos 300, that equals 0. So now we can go ahead and do our substitution. So the known values are AB. We don't know what BC and CD would be at the moment. So now in this equation, we only have BC as an unknown, whereas down here, we have BC and CD as unknowns. So what that should mean for you is we need to solve vertical force components first. So let's do the solving then. So we have minus there, negative 15 there. We already know what AB is. AB is negative 15.59. That's sin 240. We don't know what BC is, so we're just going to have plus BC sin 300 equals 0. So what we have to do now, we just need to work out all of this bit right there, and that's just simply minus 15, and if we put that bit in calculator, we get plus 13.50. And in the next step, I'm just going to get to the answer for BC, just to shorten things a little. So therefore, BC would be equal to, so we're just literally gonna transpose that bit there, negative 15 plus 13.50, and divide that by sin 300 to get BC, and that would be negative 1.73. I've just cut to the chase just to save some space and speed things up a bit. So now we are going to solve the horizontal component bit, and we will now have only one unknown because we've just calculated BC and we already know what AB is. So for this one, we have CD, and for AB, once again, negative 15.59, and we're doing cos 240. We already know what BC is. BC is negative 1.73, and that's going to be cos 300 equals 0. So this one's going to be quite straightforward because once we solve these bits, so negative 15.59 cos 240, that's now plus 7.80 minus that last bit 0.87 equals 0. So therefore our CD value is negative 6.93 newtons. And that's it. We have BC, we have CD, we also calculated previously our AB and BG. Now in the next step, you might be tempted to go to this next corner right here. But if we were to do that, both of our equations will have two unknowns, and that would make it simply unsolvable for the approach that we're taking. So what we will do next is to go to this next corner right here. So I'm going to isolate that bit there at R2 joint. So let's do that. So at joint R2, once again, we're going to do our vertical force components and our horizontal force components. So what that will look like is we have R2 going up, and then we're going to do the same thing. So for EF, just imagine once again that we're measuring the angle counterclockwise from the right, and that would look like so. So that would make this angle here 120 degrees. So that's how we get the angle there. So we have R2 plus EF, and that's sin 120. So that's it for this equation, because we won't have any force for that horizontal member EG. So we're going to go ahead and solve this now. And we already know that R2 is 10.50. So that leaves us with just EF to solve. So let's solve for EF, and we'll cut to the chase once again. So for EF, it's just simply going to be negative 10.50 divided by sin 120. That gives us for EF negative 12.12 newtons. So that's it for EF. And then we need to find EG, and EG is our horizontal component. That's where that's going to come out, because it's purely horizontal. So what we will have is EG plus EF and cos 120. Notice the angle is always the same for the corresponding members. So for EG, we already know what EF is, so let's just put that in, negative 12.12 and cos 120 equals 0. So our EG, when we just work all of that out, will turn out to be negative 6.06 newtons. So that's it then. So with those 6 forces that we have found, it means we only have one unknown member, and that's the member right here, member CE. And to find member CE, we can use either the joint at the top right or the joint at the middle there at the bottom. So I'm going to use just the top right. So we are now after the final member, which is member CE, and I'll just use the vertical force components to do that. And what that will look like is we have that 9 newtons going down, so minus 9 because it's going down. And then we have member CE and its angle. Once again, if we were to do a dotted line like that, the angle measured is right there. So it's going to be CE sin, and that's 180 plus 60, so sin 240. And then the EF member now is just going to be another 60 degrees going in that same direction. So it's EF sin 300 equal 0. So to cut to the chase, we already have EE, we already have EF. So let's just substitute those values. So CE would be equal to, so that's just simply going to be 9 minus 10.50, and that's all going to be divided by sin 300, which gives us 1.73 newtons, and that's our final member. So that's it. We have all our members analyzed. We have the force that's going through the members, and if the answer is positive, we already know that that member is in tension. And if the answer is negative, we know that the member is a compressive member. So hope you have found some value from this video. And if you have learned anything, please like the video, share the video to someone who you think might need the help, and subscribe to the channel. And I will see you in the next one.